demultiplexing, and here I have logged onto Orion now with RStudio and here with my terminal. So first of all, make a folder where you are going to run all your scripts for this particular project. I make a folder called tutorial here now, and then we step into that. And of course here there should be nothing now. In RStudio we also locate the same folder. I need to refresh here, tutorial, and there it is, empty. Okay, start by copying the demultiplex script from the folder under my home here on Orion, and that's this one, MNT users and my username. There is an address in that help document, and under here you should look into the folder called MiDiv, and then Amplicon sequencing Illumina, and there should be the script we're talking about, the MiDiv demultiplex.sh. Copy it here. So now we should have this, and we refresh to see it's open. It's here as well. Click it open. So what you need to edit here is first, you can of course edit the time now. It shouldn't really be necessary because 50 gigabytes should be more than enough for even for the biggest data set, because this does not use much memory per data. It will read one data set at a time, one file at a time. So even if there are enormous number of files, it shouldn't require more memory. What you have to edit is this raw data folder, because this is where your data, and I will not edit it now because I use this tutorial data, but you will typically have to change this last part here. It should be on the rest of the parts should actually be the same, I think. And in that folder there will also be a Excel file with the metadata. So you see I make use of that folder information here now, and say that inside that folder there should be this Excel file. Then you need to output, and now I call this output folder SRA ready. And of course you can give this any name. The reason I use this name now is that from this 2.2 version of the MiDiv package, the primers are actually removed in this step here. So the reads we get in that output folder now should be ready for upload to SRA. That's why I named the folder exactly that, to remind me of this. And you need a temporary output folder that you can delete. It's for this temporary computations here. Vsearch and FastQC, yeah, we can see. And nothing else should actually be changed here now. So once you are happy with this, you save it. And of course, since I never changed anything, I don't need to save it. And then we just sbatch. Make sure you are in the folder where this is located, and then you sbatch this to the Slurm. And of course, how long time this takes depends on how many datasets you have and how many other users there are on Orion. It looks like it has started at least. You can see the log file was created, the output folder was created, and the temporary folder was created, but it hasn't really started doing anything yet. So we will have to inspect the, it's been running on, it's running on CN1. That it's normally not the slowest node, but we will have to wait. Okay, so now the script is done. We can see the log file is here and it has got some size. You can click it open and inspect it if you like. It's not very exciting. As long as things are working, it's fine. And most of it is this output from this FastQC actually. I will not dig into it. The output, yeah, we can open this folder here to see that now we have the FastQ files. And Also for each FASTQ file there is an HTML file with this FASTQC reports. So, and those you can open here, right? You can click on it, left click, and view in browser. So you can actually look at this report, see the quality of the bases and so on. For each and every file, actually. You can actually delete this if you don't need them, but they don't take up super much space, so it's okay to have them, I think. So this is now the SRA ready files. In addition to this, there is also this at the very end of the script here. There is some R code to produce this figure here. Let's have a look at it. We just click it open like this, and this is meant to be a guide for later processing. So the first panel up here shows you now a histogram over amplicon lengths. So a few samples, I think it was 3 by default, 3 random samples were merged by vSearch, and then we can see how long are the merged reads, right? And they are typically up to 430 or something bases, something around 430, I think, after merging. Yeah, some are shorter. This is the overlap between the reads when they merge. How long do they overlap each other? And we can see all of them are overlapping well over 100 bases. And this is actually more than enough. Actually, it's a little bit too long, I would say, because we know that at the 3' end of the sequences of the reads, we have the poor quality. We saw that actually let me go back to this. Here, we can open this one. You see the quality drops towards the end here. And when you merge R and R2 reads, this is the region you use, right? This is where they overlap each other at this end of the read. So it's not necessary to have this long overlap. So it's tempting now to trim the reads. Cut out this poor part. Stop here, right? Something like that. Because then, okay, the overlap will be shorter, but it will be less noisy. So hopefully more reads will overlap. So that's what this plot is about, to guide you how much can you trim. It said it should be at least 25 bases, right? So you cannot trim down here. You have to leave some overlap, right? And 25 is probably a very, very minimum. It should actually be a little bit longer. So, but here we can afford to trim, I would say, at least 50 bases and even more. This one here is just another sort of version of the plot you saw here, the scores. But this is only the 10% poorest score and the average of all the reads in these 3 random samples. So you can see here that, for instance, the R2 reads, they have pretty low score here towards the end, right? So this is from the end, the 3' end and upwards. So getting rid of this part would be beneficial, I think. And if you see the quality score of 20 is considered a very good score. So, okay, I could easily be willing to trim at least down here, right? And perhaps even longer, even down here, 60 bases. But not 80, I think. That's... and of course, if I trim the R2 read a lot, you cannot trim the R1 read a lot, because then you lose your overlap, right? So you can see that the total amount of bases that you trim from these two together must not add up to more than what you can afford up here, right? So I think that the default now in the scripts are to trim R2 reads with 60 bases and R1 read with 20 bases. So we all together remove 80, right? But this, you have to make up your own mind, because this will vary from dataset to dataset. OK, then demultiplexing is done.